the people waiting or they are not waiting enough. So I checked, nobody, only one person mentioned they were like, okay.
One person means nobody.
Okay.
Good day, everyone. I believe you are all doing well by God's grace. Yeah, so today we are going to talk about some concepts in applied electricity, and I'd like you to pay close attention to what we are about to do today because it's going to be a very comprehensive tutorial session. And do what also write notes as well. Right? If there is a problem you don't understand, you can always leave it in the comment section or visit it back once you are done with the session. Right. So today we are going to deal with series arrangement, series and parallel arrangement, arrangement of resistors, resistors in circuits. Good. So I believe you know what a resistor is, and this session is more of a practical session. So we are just going to dive into the practical side of it, right? The theoretical side you can always read and understand it better, right? But then when we talk about resistors, resistors are elements in electrical circuits which present opposition to current flow in the circuit, right? And you know that R is equal to V over I, right? So that's just the basic. You know that resistor opposes the flow of current in a circuit, right? So today we are going to dive into series and parallel arrangement of resistors in circuits, right? So kindly pay much attention to what I'm about to do, then we can take it from there, right? Good. So first we are going to start with series arrangement. So we are going to start with series arrangement. Good. Now we say two or more resistors are said to be in series when the same current flows through each of them. All right, so let's look at an example. We have a circuit here with voltage here, right? And we have R1 here, R2 here. So this is the circuit we are talking about, right? Good. And we are saying that two or more resistors are said to be in series when the same current flow through each of them. Right? So realize that I can tell you that R1 and R2 are in series because they would have the same current flowing through them. You know voltage drives current, right? Good. So if I have I here, this R1 gets the same current which is moving from this voltage, and this R2 also gets the same current. So with this analysis, we can say that R1 and R2 are in series. So two resistors are said to be in series when the same current flows through each of them, right? Good. Now let's look at another circuit and let's make some analysis. So let's take this circuit, right? We have V here, we have R1 here, we have R3 here, we have R2 here, right? Good. Now let's name something here. I believe they've taught you what a node is, right? I would explain it for you recently, but then just let me just put it here for you to understand it better. All right. So when you look at this particular circuit, you realize that R1 and R2 are not in series because there is a node here. There is a node here. And then when you talk about a node is any point in a circuit where currents can divide or add. right? So that is what a node is. And when there is a presence of a node in a circuit, we are saying that a node is any point in a circuit where currents can add or divide. So if currents add or they divide, then it means that the nature of the current would change. So in that sense, you are saying that the current would not be the same. So as soon as you have node between two resistors, it prevents it from being in series arrangement, right? So with this circuit, you can say that although I've not introduced parallel to you yet, but you can't say that R1 and R2 R2 are in series. No, because there is a node here. As soon as current moves from this voltage, when it gets to this node, the current will split. So R3 will have its own current, and then R2 also have its own current. So R1 and R2 are not in series. Please get that difference very well. So when you have to find the total resistance in a circuit where you have two series arrangements, the formula is just RT is equal to R1 plus R2. So that's when they are in series, as simple as ABC, right? Good. So let's look at an example and let's see how we can explain that based on the concept we just learned. Good. So we are going to take an example. Then we see the resistors which are in series, and then the resistors which are not in series. So let me quickly draw the diagram. Then we can take it from there. Good. So we have R1 here, we have R2 here, then we have R3 here. Let's put another resistance here. So let's say we have R4 here, then we have R5 here, and then R6 here. So the question is, which of the resistors in the circuit are in series? Alright, so let's do the analysis very well. So first, I can tell you that R1 and R2 are in series. The reason is because R1 and R2 would have the same current flowing through them. There is no node between the two resistors. I told you that when current flows, the same current flows through two resistors, they are in series. But then as soon as you get a node between the two resistors, it prevents it from being in series arrangement, right? This is not a node. Please take note. When I was in first year, a lot of students had this confusion. This is just like a connection. This is just like a wire. You can straighten it. You get it. So put that in mind that you can straighten it. So that is not a node. When current gets to this point, current is not going to split. It's not going to split. It's not going to divide, or it's not going to add. So this is not a node. So this is not a node. Please take note. This is not a node, right? Good. So we can say that R1 and R2 are in series. Now let's look at another one, R5 and R6. So we can also say that R5 and R6 are in what? Series. The reason is because one, there is no node between R5 and R6, right? So if there is no node, then it means that the same current will flow through R5 and R6, making it have a series arrangement. Right, now let's take R3 and R4. This is R3, this is R4. Now with R3 and R4,